This video introduces JSON. Let's start by talking about its pronunciation. Some people call it JSON and some call it JSON. I did a little bit of investigation and discovered that the original developer of JSON calls it JSON, so I'll do that too. Like XML, JSON can be thought of as a data model, an alternative to the relational data model that is more appropriate for semi-structured data. In this video, I'll introduce the basics of JSON, and I'll also compare JSON to the relational data model, and I'll compare it to XML. But it's not crucial to have watched those videos to get something out of this one. Now, among the three models, the relational model, XML, and JSON, JSON is by a large margin the newest, and it does show there aren't as many tools for JSON as we have for XML, and certainly not as we have for relational. JSON stands for JavaScript Object Notation, although it's evolved to become pretty much independent of JavaScript at this point. The little snippet of JSON in the corner is right now mostly for decoration. We'll talk about the details in just a minute. Now, JSON was designed originally for what's called serializing data objects, that is, taking data objects that are in a program and sort of writing them down in a serial fashion, typically in files. One thing about JSON is that it is human readable, similar to the way XML is human readable, and it's often used for data interchange. So for writing out, say, the objects in a program so they can be exchanged with another program and read into that one. Also, just more generally, because JSON is not as rigid as the relational model, it's generally useful for representing and for storing data that doesn't have rigid structure, that we've been calling semi-structured data. As I mentioned, JSON is no longer closely tied to JavaScript. Many different programming languages do have parsers for reading JSON data into the program and for writing out JSON data as well. Now let's talk about the basic constructs in JSON. And as we will see, these constructs are recursively defined. We'll use the example JSON data shown on the screen, and that data is also available in a file for download from the website. The basic atomic values in JSON are fairly typical. We have numbers, we have strings, we also have Boolean values, although there are none of those in this example. That's true and false, and null values. There are two types of composite values in JSON, objects and arrays. Objects are enclosed in curly braces, and they consist of sets of label value pairs. For example, we have an object here that has a first name and a last name. We have a more bigger, let's say, object here that has ISBN, price, edition, and so on. When we do our JSON demo, we'll go into these constructs in more detail. At this point, we're just introducing them. The second type of composite value in JSON is arrays, and arrays are enclosed in square brackets with commas between the array elements. Actually, we had commas in the objects as well. And arrays are lists of values. For example, we can see here that authors is a list of author objects. Now, I mentioned that the constructs are recursive. Specifically, the values inside arrays can be anything. They can be other arrays or objects, base values. And the values making up the label value pairs in objects can also be any composite value or a base value. And I did want to mention, by the way, that sometimes this word label here for label value pairs is called a property. So just like XML, JSON has some basic structural requirements in its format, but it doesn't have a lot of requirements in terms of uniformity. We have a couple of examples of heterogeneity in here. For example, this book has an addition and the other one doesn't. This book has a remark and the other one doesn't. But we'll see many more examples of heterogeneity when we do the demo and look into JSON data in more detail. Now let's compare JSON and the relational model. We will see that many of the comparisons are fairly similar to when we compared XML to the relational model. Let's start with the basic structures underlying the data model. So the relational model is based on tables. We set up a structure of tables, a set of columns, and then the data becomes rows in those tables. JSON is based instead on sets, the sets of label value pairs and arrays, and as we saw, they can be nested. One of the big differences between the two models, of course, is the schema. So the relational model has a schema fixed in advance. You set it up before you have any data loaded, and then all data needs to conform to that schema. JSON, on the other hand, typically does not require a schema in advance. In fact, the schema and the data are kind of mixed up together, just like in XML, and this is often referred to as self-describing data, where the schema elements are within the data itself. And this is, of course, typically more flexible than the relational model, though there are advantages to having schema as well, definitely. As far as queries go, one of the nice features of the relational model is that there are simple, expressive languages for querying the database. In terms of JSON, although a few things have been proposed, at this point there's nothing widely used for querying JSON data. Typically, JSON data is read into a program and it's manipulated programmatically. Now let me interject that this video is being made in February 2012. So it is possible that some JSON query languages will emerge and become widely used. There's just nothing used at this point. There are some proposals. There's a JSON path language, JSON query, a language called Jackal. It may be that just like XML, the query languages are going to follow the prevalent use of the data format or data model, but that has not happened yet as of February 2012. How about ordering? One aspect of the relational model is that it's an unordered model. It's based on sets, and if we want to see relational data in sorted order, then we put that inside a query. In JSON, we have arrays as one of the basic data structures, and arrays are ordered. Of course, there's also the fact, like XML, that JSON data is usually written to files, and files themselves are naturally ordered. But the ordering of data in files usually isn't relevant. Sometimes it is, but typically not. Finally, in terms of implementation, for the relational model, there are systems that implement the relational model natively. They're very mature, generally quite efficient and powerful systems. For JSON, we haven't yet seen standalone database systems that use JSON as their data model. Instead, JSON is more typically coupled with programming languages. One thing I should add, however, is that JSON is used in NoSQL systems. We do have videos about NoSQL systems. You may or may not have watched those yet. There's a couple of different ways that JSON is used in those systems. One of them is just as the format for reading data into the systems and writing data out from the systems. The other way it's used is that some of the NoSQL systems are what are called document management systems, where the documents themselves may contain JSON data, and then the systems will have special features for manipulating the JSON in the documents that are stored by the system.